Okay, 6th grade, happy Tuesday. Our objective today is to talk about similar and congruent figures, bless you, and to still continue talking about proportions, word problems, using proportions. So that's our plan. We are moving pretty quickly through this chapter. You guys are doing extremely well. So I anticipate your 6-1 to 6-6 quiz to be Friday or Monday, but I'm leaning more towards Monday, okay? I shouldn't have a better idea of that tomorrow. I just like to give you a heads up. So the earliest it could be is this Friday, but I'm guessing it won't be until Monday, okay? It just depends on how you guys do today and tomorrow. So let's start with going over the second warm-up. I know you didn't all get both of these done, but at least make sure you have the problems written down, okay? It's a warm-up, so it's to get you guys thinking and to review things. So who got the answer to number 1 that would like to tell us? Justin? Nope. Close though. Something over 6. Emma? Good. X equals -1/6. On this one, don't forget, if you have 2 ratios set equal to each other, you're using cross products, okay, to solve, to simplify. Someone's at the door. They left. Thank you, though, Matt. Adam? No. When can you cross simplify? Alyssa? Good. When there's a multiplication symbol between them, that's when you can cross simplify. Now, you could, like Adam, if this could be simplified, then you can simplify it. But don't cross simplify. Okay? Okay, the second one. Annalise. Good job. X equals 5. Okay, before we go over the second warm-up, questions on either one of those? Annalise? Same thing. It's just the decimal. You're good. Same thing. Yeah, it's the same thing. Anyone else? Questions on 1 or 2? Justin? Okay, so let me at least start it for you. Tell me when or if you find your mistake, okay? So 4 times 4x minus 1, okay, equal to 2x minus 3. So did you set it up like that? Oh. Okay, so 16x minus 4 equals 4x minus 6. That works. Did you have that? Okay. Did you move then 4x to the other side? So minus 4x minus 4x. So we have 12x minus 4 equals -6. Did you still have that? That's why. Because then when you add 4 to both sides, we get 12x equals -2. And then divide by 12, you get -2 over 12, which is -1/6. You okay? Okay, anyone else on that warm-up? Okay, let's go over the second warm-up, or I should really say the first warm-up. Okay, Briar, number 1. Good. Number 2, Sean. Good. Annalise, number 3. Good. Zach, number 4. Nope. That one's tricky. Alyssa? Good. B. Number 5, Charles? Good. Mary, number 6? Okay. Adam, number 6? Nope. Number 6, Emma H? Good. Emma H, tell me, I don't know if you wrote down your work, but can you tell us your proportion you used? Awesome. Great job. That one was a little tricky. Perfect. What'd you use, Charles? Perfect. And Charles, you just did what Adam was kind of asking about. You simplified this. Yeah. So do you understand, Adam, that okay. I know you're asking about cross, but just FYI, you can simplify the fraction. So yep, Charles, that's perfect. Okay, number 7, Donatus. Yeah, number 7. Did you do 8 or 9? Okay, Donatus, just like following directions on the homework. Look, did you see that? Okay. Justin, number 7. Good, 48 pounds of oranges. Number 8, Matt. Good, $2.70. Perfect. Doug, number 9. 23 gallons. Good. Number 10, Mary. 90 or 92? Good, calories. All right, questions on those? Annalise? Okay, did you look at the proportion that Emma told us? Okay, so this is red stamp. The top is red stamp, the bottom is people. Yes. So basically you have enough information. You know the sample of people is 250, okay? You know that 4 people in the crowd out of those 250 had a red stamp, so 4 over 250. And then you know that they randomly stamped 120 people's hands, but you need to figure out how many people are in the crowd if they randomly stamped 120 people's hands. So 120 with the red stamp. Well, how many were in the crowd if that many had the red stamp? This is just like all the others, but I highly suggest that you write down the 2 different items that they're talking about. Red stamp, people. Okay, I just explained that. You may explain it again. 120 people have a red stamp on their hand. Okay, that's how many have red stamps, but you don't know how many people total are in the crowd. You have to find the total. Yep. 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 Emma M? Go ahead. You probably just did it in your head. That's fine. 5. Okay. Okay, 5, you should have miles and minutes. So did you not know where to start your proportion? Was that the problem? Okay. Where's mine? Okay, so we have 29.2 miles in 2 hours. Okay, you need to convert hours to minutes. No, because it asks you, at this rate, how far can the same cyclist travel in 45 minutes? So no, you have to convert it to minutes because that's what it's asking us about. So I think you should be okay, right? Doug? $11 is 4.03. 2.75. Okay, anyone else? Questions for 1 through 10? Positive? Give me a thumbs up, thumbs middle, thumbs down on the warm-up. I know it was kind of long, but Donatus? Thank you. All right, homework. Okay, homework page. What page was that? 286? Hi. Oh, let me give you the card. 6th grade, hold on 1 second. Is this for both of them or just Julie? So, yeah, that's perfect. I'll record that later. Take your time. Okay, homework page 286, number 1. Zach, what'd you get? Oh, sorry, I thought you were there. Annalise, number 1. Good. M, N, and P. So there's a ton of points you can have. You only had to name 3. You could have M, N, N, P, R, S. You could have any of those 3. Okay? Jeremy. No, you just have to name them. If you put the point above it, that works, but you didn't have to. Mrs. Angeloff, I will have Mrs. Root bring you the other card, okay? Or we'll just sign it. Thank you. Okay. And I'll give her the other money. So, Jeremy, does that make sense? Okay. Alyssa, number 2, please. Good. MN and RS. Make sure you have the line above it. That means arrows are going on in both directions. Matt, number 3. Or go ahead. Yes, sorry. Yep. NP is perfect. Did anyone have any other lines for number 2? Doug? Say that again? Where'd you get B? No. PN. Yeah, that's what Matt just said. Anyone else? Annalise? Ooh, yeah, that would be good that I didn't see that arrow. Thank you. Sorry. Matt, that's not right. Annalise, thank you. For some reason, I thought I saw the arrow. Thank you. Please check me. I do make mistakes sometimes. So, Matt, sorry. It is not a line. It's a ray because it stops there. I looked at my paper real quick, and I was thinking there was an arrow on both sides. Yep, there are only those two. I got distracted when someone knocked at the door. So there are only two lines. I think Annalise should come up here and teach. Okay, number 3. Okay, name 2 planes. Charles, 2 planes. Awesome. Plane MNP is a plane. What else could you name plane MNP? Matt? Awesome. Could also name it plane Y. So I think I just wrote up here, yeah. I wrote plane Y and plane Z, but again, you may also have MNP because it's 3 points not on the same line. Annalise?
Can you write it as like the square instead of letters?
Yep. Yep. Well, in front of it. If you use the plane symbol, you would do like plane Z. Okay. That's an option for quadrilateral, yeah. Yeah, you just have to know what the question is. Typically, you'll see it written with the word plane. You don't typically see it with the drawing, but it is an option. Sean? Yep. Yep. Because there's only 2 points on there, so you can't use points. Okay, number 4, Briar, 2 rays. R, S, and NP. Good. There's 2 more. Anyone have other rays? Charles? Good. There was 1 more, but did anyone have any other rays? Okay. So I put, hold on, I'll show you why. I put NP, MN, RS, so that's all I put. Anyways, there's 3 of them. You could also say, SR because technically if you're using S as the end point, you still could consider this an end point, even though it does go on forever, as long as you use your notation correctly when you're writing it. So if you did use SR, you would have to just use that notation of a ray, because you still can pull a ray out of a line if need be. Okay? It's not as common, but you still can. Annalise?
Do you have to use letters?
Yes, have to. Yes. Doug? No. Okay, number 5, name a segment. So, Alyssa, give us a segment that you used. Say that again? Yeah, for 5, yeah. Good. RS, what's another one, Charles? Okay. Emma H, what's another one? Good. NP, what's another one, Sean? Good. MN. So, segments, I think I wrote a bunch of them. Yeah, I wrote PN, MN, RS, NP, SR. Just make sure that you have the lines above it to indicate that they're segments. Yeah. Yep. And you can also have a line with 2 dots. So there's a couple ways you could do this. Most commonly, Charles, you'll see it as a line with no dots for a segment. So most commonly in geometry, you'll just see a line above it, which indicates it's a segment. Okay. Zach? Yes. Depending on how you have the notation, yes. Make sense? Okay, and then the last one in that section, number 6, is the measure of the angle is 85 degrees. So you need to write it as measure of angle MNF is 85 degrees, or measure of angle N is 85 degrees. So remember, when you're finding the measurement of something, okay, you need to use the little m. Just naming the angle is angle MNP or angle N. You could also name it as angle, I didn't mean to say F, that was a P. You could also name it as angle PNM. Remember, as long as the vertex is in the middle, there's a couple ways to name it. Melissa? No. You could have just picked one way. So as long as you had either this or this and this or this, you're fine. Okay, anyone else on number 6? Okay, number 7, you had to name the quadrilateral. So you could have either put quadrilateral DEFG or drew a picture in front of it that has 4 sides. Anything that has 4 sides is a quadrilateral. Number 8, you had to name the sides. They are all segments. So you should have DE, EF, GH. Why did I say H? I don't know. GF, GD. You could have also had them reversed, like ED, FE, FG. Okay, it does not have to be in that exact order. Briar? Well, it is a parallelogram. No, you're correct. It just meant using notation. But to be honest, I wouldn't have marked that wrong because you're right. You are specifically naming the quadrilateral. That's chapter 8 in geometry. You guys will do that. Yeah, exactly. Okay, number 9, naming the angles. I named them with 3 letters. You may also just name them with the vertices. So angle DGF, okay, angle GFE, angle FED, angle EDG. You may also name them as angle G, angle F, angle E, angle D. Don't have the M in front of it because you're just naming it. You're not giving the measurement, you're just naming it. Doug? For an angle? You just need the angle symbol in front. Oh, we already did that one. You have to have the line above it for sides. Well, yeah, you're right. But again, most commonly you'll see that there. You won't see the dots. Typically you'll see a line above it. And then 10, indicate what's congruent, the angles and sides. So starting with sides, GF, segment GF is congruent to segment DE. Segment DG is congruent to segment EF. And then angle G is congruent to angle E, which you could also say as angle DGF, congruent to angle FED. And then angle D is congruent to angle F, which you may also say as angle GDE, congruent to angle EFG. Annalise. Okay. Any questions on homework? Doug? Yep, I said that. That's okay. I read both answers. Annalise? You said to name the angle and give the measurement. Well, you only knew the measurement to one of them. So, yeah, you could have had either one of those, but there's only one angle that you know for sure is 85 degrees. Okay? Well, actually, RS is a straight angle, which is 180 degrees. So, there's actually another one. Yeah. I didn't actually teach it to you, but you should know it, I'm guessing. You guys learned straight angles, right? Okay. So you could have put that. And you actually also know what angle PN, whatever that other letter is. You could also figure out this angle because these two add up to 180. So you can also find this angle. So you'll do a lot of that in geometry. Okay, anything else on homework before we start the notes? Okay, so not bad. Okay, turn, Jeremy. Oh, yeah, thank you. Okay, sorry, I forgot about that. Thanks, Jeremy. Open up your notes to page 10 so we can go over those 2 examples, and then we'll move back to the notes. Okay, these should have been pretty easy. Okay, so that first example on page 10, okay, first thing you had to do was name 2 segments. So on page 10 of your notes, Adam, what's one segment you wrote down? PM, is that what you said? N, okay. So, and what's the measurement of it? Good job. Okay, what's another segment? Mary? Good, PM, what's the measurement of it? Good job. Okay, you need to name 2 rays. So, Charles, what's one ray? Okay, what's the notation? Good. What's the other one? Good. With the ray above it. Perfect. Okay, Annalise, what's the angle? Okay, so you did M, P, N first as the name, and then you did measurement of angle, MPN is 80 degrees. So you want to have two things, the name plus the measurement. The M indicates what the measurement is, but it says write down what the angle is and its measurement. So in my mind, you should still label what it is, MPN. You may also have angle NPM. You may also have angle P. Briar? No, it's not saying it's congruent. That's what it's equal to. Okay, we're going to talk much more about congruent today, so good question. All right, let's go to that second example, which was underneath the chart. Okay, identify the following. So you have to label three angles. One of them is angle YXZ. Another one is angle XYZ. Third one is angle YZX. The sides, we have XY, we have YZ, and we have XZ. Remember, in any order. Congruent angles, I'm going to let you guys tell me this. What are two congruent angles in that figure? Doug? Good. Angle X, so I'm going to put angle YXZ is congruent to angle YZX. And what about congruent sides? Sean, what are the congruent sides? Good. XY is congruent to YZ. Do not forget the congruent symbol is an equal sign with a squiggle above it. Charles. Yep, that's today's lesson. Yep. Okay, any questions from the homework before we, for real this time, go to the notes? Thanks, Jeremy, for reminding me. Adam. Yeah. All right, now notes page 11. Okay, we're going to start off with some, well, objective first. Okay, so we're going to talk about similar and congruent figures today. I have on the board the symbol for congruent, okay, which is an equal sign with a line above it, or equal sign with a squiggle line above it, I should say more specifically. We talked a lot about that yesterday, but we're talking more about it today. The symbol for similar, like Charles said, is just a squiggly line. So this means figures are similar. Anyone know what the difference between congruent and similar is? Big difference. Justin, do you know? Good. Good. Awesome. Anyone want to add anything to that? Jeremy? Awesome. Briar? Yep. Doug, you want to add something different? Very good. All the side lengths have to be proportional in a similar figure. In other words, it's going to have the same scale factor going from each side of the original to the new. So we're going to talk about proportions today, scale factors today, the difference between congruent and similar, and we'll see what we get through. Okay, in the chart on page 11, there are three terms we have to talk about: congruent, similar, and corresponding parts. So let's start with congruent. Okay, jot down whatever you need to. In the left-hand side of the chart, I want you to write down congruent, two figures that have the same shape and size. On the right-hand side of the box, I want you to draw that picture, and I will explain it once you get there. So congruent, two figures that have the same shape and size. So after you write that down, I just want you to draw these two triangles and we'll label things together so that you're not confused. Okay, so if they're congruent, they have the same shape and size. So with me, that means A and D are congruent. They're corresponding angles. They are in the same relative position. That means angle B and E are congruent. That means you draw two little curvy lines to indicate these are congruent. And then for the third angle, draw three curvy lines for C and F. That means they are congruent. I know. On the sides, AC is congruent to what? What's AC congruent to, Annalise? Good. What's AB congruent to? Side AB, Briar. Good. Use 2 tick marks. And then BC, use 3 tick marks, congruent to EF. What is a congruent statement that you can write for these triangles? Charles, what's the congruent statement? Okay, tell me why it has to go in that order. Okay, yeah, and the A goes with the D, the B goes with the E, the C, so they're in the same relative position. Correct. You could also do triangle CBA is congruent to triangle FED. So there's a lot of ways to do it. Hold on, Adam. But however you do it, they have to correspond. There's about 6 different ways you could say this, okay? So any questions on how to write that? Mary, do you have a question? It would. You'll learn about regular octagons, which means everything in them is congruent. Okay, are these 2 questions related, guys? Then hold yours. Annalise, go ahead. Yep. Donatus? Well, it looks like an equal angular and equilateral, but it's not always drawn to scale. So you can't assume that. Okay? Good question, Donatus. Okay, second one, similar figures, which you guys basically told us. 2 figures that have the same shape, but not necessarily the same size. 2 figures that have the same shape, but not necessarily the same size. And I'll explain that picture once you guys jot that down. Sean? Yep. Because incongruent, every single thing is the same. So you could also say it's similar. Correct. Yes, correct. Jeremy? No. Nope. Okay, after you write down the definition of similar, I want you to draw these 2 triangles, A, B, C, D, E, F. And I want you to label the sides, and I want you to figure out why I chose to label them the way I did, after you write it down, of course. So after you write that, go ahead and draw those 2 triangles, and I want you to tell me why I wrote them, why I drew them the way I did this morning.
You mean like the length of the sides?
Yep. 7's not there for a reason, Charles. Once you figure out why I labeled the sides the way I did, I want you to put your hand up. Okay, Briar, why? Why are they like that? So the scale factor from here to here is times 2. What about the proportions? What are the proportions? So a proportion from small to big. What is the proportion of every side? Annalise? And what are they all reduced to? Yep. So what I wanted to hear is the proportion from small to large is 1/2. The scale factor from small to large is times 2. What's the scale factor from large to small? So going this way, what's the scale factor? Adam? Awesome. Times 1/2. Do you guys see that? There's 2 different scale factors depending on which way you go. This way is times 2. This way is times 1/2. Okay. All right. Yep. 2 more things I want you to write down on the right-hand side. So for similar figures, if you have room, or you can just draw my pictures. What I wrote in green is fine. For similar figures, corresponding angles have to be congruent. For similar figures, corresponding angles have to be congruent. Number 2, Doug told us this a while ago, the ratios of the lengths of the corresponding sides are equal. The ratios of the lengths of the corresponding sides are equal. So I just wrote down AB over DE, which is the 4 and the 8, is equal to AC over DF, which is the 3 over 6, which is equal to CB over FE, which is what Annalise told us, which is the 5 over 10. So the proportions all end up equaling 1/2. The ratios are equal. So ratios of the side lengths are equivalent. So for similar, angles have to be the same, the sides are in proportion. Okay, when you're done with that, I want you to look at example 1. Go ahead, Charles. Yeah, if you multiply every side by 2 on triangle ABC, you get the triangle DEF. The word that you'll say is the scale factor. The scale factor of triangle ABC to DEF is 2. So yes, you say that a lot in geometry. That's why I'm talking about that now. Yep. But you always hear the word scale factor. Okay, when you guys are done, just look at example 1, but don't start it yet. So the biggest thing today is learning the difference between congruent and similar. Okay, can I move? Okay, example, oh, I forgot, never mind, sorry, I forgot a definition. Sorry, guys. I forgot about corresponding parts. My fault. Sorry. Corresponding parts is important. I forgot, sorry. Corresponding parts. Sides or angles that have the same relative position. We've already talked a lot about this, which is probably why I forgot it. Corresponding parts. Sides or angles that have the same relative position. For example, A and D are corresponding because they're in the same position. B and E are corresponding. They're in the same position. C and F are corresponding. They're in the same position. Just like AC and DF are corresponding. They're in the same position. So I could keep going. Typically for corresponding parts, so if we were to say angle A corresponds with angle D, you will either see the similar symbol or the congruent symbol. Sometimes you'll see congruent, especially if they're angles, because you know they're going to be the same. So it depends on what it is. So either the similar, the squiggle, or the congruent. It depends on what the figures are. We'll get to that. For now, does everyone understand what I mean by corresponding in the same relative position? Give me a head nod. Okay, sorry, I almost forgot about it. Okay, now let's look at the first example for real this time. Okay, so now we have a very cool trapezoid. It tells us that trapezoid LMNP is similar to trapezoid QRST. What do you notice about the diagram that's kind of annoying? At least in my mind, it's kind of annoying. Justin? Yeah, QRST is upside down. I want you guys to cross this off. Okay, let's redraw it so it's not upside down. We're going to look at that right now. So I want you to first draw a trapezoid that is the normal way, like LMNP. How are we going to draw the new QRST? Alyssa, how are we going to draw it? How do you know that? Awesome. You have to either go clockwise or counterclockwise. Since this triangle goes L, M, N, P, you have to go Q, R, S, T. Same relative position, same direction. So both of them are going this direction. Just like I told you yesterday. But now we're actually using that word corresponding parts. On a test, on homework, I recommend that you redraw it, okay, just like we did, so that the corresponding parts are matched up. Sean? There's probably no reason. I don't think that matters at all. Okay, so after you redraw them, we need to list all pairs of corresponding sides of these two figures. So the figures are similar. That means the sides are proportional. So we're going to use the little squiggle line, similar symbol for these. What's one set of corresponding sides? Annalise, what's one? Good. LP, put a squiggle, is corresponding to QT. Okay, let's do one more. What's one more? I know there's 4, but we're just going to do one more. Emma H. Good. PN and TS are corresponding. They are in the same relative location. Justin? This P? BR? Or did I mess up? PN? No, that's right. That's right. Charles? Yes, you may. Okay, corresponding angles. Give me one set of corresponding angles. We'll do 2 for this too. Doug? Okay, so in similar figures, the angles are always what? Okay, and in similar figures, the angles are always congruent. So angle P, Doug, is congruent to angle. Okay, what's the angle? I didn't remember. Good. Okay. What's another set of angles that's corresponding, but since they're similar, they're congruent? Mary? Awesome. Angle M is congruent to angle R. Is this easy? Okay, Annalise? All the angles. In a similar figure, Annalise, just like we wrote down for the definition, all the angles are the same. The sides are proportional. Always. Anyone else? Okay, let's go to example 2. I'm going to do 2 more examples with you. Okay, example 2, it says, find the ratio of the side lengths and the unknown variables. So we know these figures are similar, okay? What is the scale factor going from here to here? So what's the scale factor, Briar, going from here to here? Awesome. So whenever I want to write down scale factor, times 5. What is the scale factor going from here to here? So we're finding scale factor right now. Matt? Okay, but scale factor always uses multiplication. Good. Times 1/5. Scale factor going from here to here is times 1/5. Guys with me? Okay, how do we find, we need to find letter B and letter A. How do we do that? How do we find B? How do we find A? Briar? Awesome. So 3 times 5 is 15. So we know B is 15. What is A? What's A, Alyssa? Awesome. 4 times 5 is 20. If you didn't know the scale factor, what could you do? Anyone know what we could do if we didn't know the scale factor? Matt? Jeremy, you okay? Okay, so I think what you're kind of saying is set up a proportion. You could also set up a proportion, kinda. You can also set up a proportion here to find the missing sides. So what I mean by that, and you don't have to write this down if you don't want, 3 and B correspond. So we could have done 3 over B equals 5 over 25 also correspond. So I want everyone to look at this. Do you guys understand how I set up this proportion? Give me a head nod. Do you understand how I set that up? 3 over B equals 5 over 25. So we went from small to big, small to big. Does it work? What do you get for B? Yeah, still works. Eventually in geometry, you will use proportions instead of scale factors because you will get to harder problems that you can't find a scale factor of. This is easy. You guys okay with that? You okay, Adam? Okay. Okay, I wanted to do one more, but we don't have time for it, so I'll save that other one for Actually, hold on. Go to the closing. Let's just set it up. I just want to talk through it because there's one homework problem like the closing. So let's just set up the closing, and then I need to explain your homework. Okay, so the closing says to estimate the height of a radio tower. You measure its shadow to be about 14 meters. The shadow of a 2-meter post is 0.4 meters. Estimate the height of the radio tower. I want everyone to draw these pictures. This is the radio tower, and this is the post. So go ahead and draw 2 triangles. I just want to label them with you so you understand how to do this. Doug, you with me? Okay. What do we know? What can we label? Mary, what do we know? Good. Here's the post, 2 meters high. What else do we know? Someone give us another piece of information. Emma M. The radio tower is not 14 meters high. The shadow. So where does the shadow go? Good. Why does it go on the bottom? Yeah. If you're standing somewhere, typically if the sun's hitting you, you're going to see your shadow on the ground. So when we label a triangle, we always have the shadow as the bottom. Have you guys done a problem like this before? Some yes, some no. Okay. What else can we label? We're not done. Annalise, what else? Good. So 0.4 meters of the post. It's very easy. What else can we label? Adam? Why? Why? Tell us why. Yeah, we've defined it. Okay, so we labeled the height is the side of the triangle, the shadow is the bottom. What is a proportion we could use to find x? If you don't know scale factors, there's 2 ways to do it. What's the proportion? Emma H. Yep. What's another proportion we could have used? That works. Annalise, what's another proportion we could have used? Yep. What's another proportion we could have used, Charles? Awesome. There's a lot of proportions we could use. Is everyone clear on how to set up a proportion? So you can use scale factors or proportions. Emma M? Oh, go ahead. Yeah, if you guys got the answer, it's 70 meters. I wasn't going to go that far, but this lesson you guys still think is easy? Okay. All right, homework. Practice 6.4, but I need to explain it all. Okay, so practice 6.4, back and front. Okay, I need to explain numbers 1 to 6 for you first. Okay, numbers 1 through 6, they do not draw the figures for you. Please draw and label them. So do you guys know what I mean by that? For 1 through 6, they give you the quadrilaterals that are similar, but they did not draw them for you. So you should be drawing 2 quadrilaterals and labeling them. I am not labeling them for you. I want you to practice labeling them on your own. 7, 8, 9, 10, and 11. Please redraw the figures so they are corresponding. Redraw the figures so they are corresponding. 8, 9, 10, 11. Redraw the figures so they are drawn the right way. Is everyone clear? Okay, good job today. Get packed up.